Hello guys, today I will explain the Bitwise OR operator, which is an operator available in C language. I will show you its symbol, explanation as to how it works, with examples and stepwise instructions. I will also provide you its truth table, the difference between Bitwise OR and logical OR, and also when and where we can use Bitwise OR, and I will also explain those things in further detail. At the end of this video, I will provide you images of my written notes. You can read those notes for further understanding and save them so that you can later review them and understand this concept better. Let's begin the lecture. Bitwise OR is basically an operator which is available in C language. There are multiple operators available in C language. Bitwise OR operator is one of the bitwise operators available in C language. Now, what is a bitwise operator? Bitwise operators are such operators which can perform bitwise operations on bits. So basically they are operators that perform some sort of operation on bits. Now I will explain bitwise OR operator. Now let's see the bitwise OR operator. The symbol of bitwise OR operator is given in the notes. It is a singular line or straight slash. Now bitwise OR operator takes 2 bits at a time and performs OR operation on them. Bitwise OR is a binary operator, meaning that it takes 2 numbers at a time and performs bitwise OR. What that means is bitwise OR takes 2 numbers, for example 7 and 4, and in the brackets I've written 7 or 4 as operands, converts those numbers into their binary representation, so their binary form, and performs OR operation on the individual aligning bits. Then it gets a binary number as a result of applying OR operation on the individual aligning bits and converts that binary number into its decimal form. I have explained this second point, with an example, but first we need to see the further 2 points. Result of OR is 1 if either bits are 1, either of the aligning bits are 1, and result of OR is 0 only if both the aligning bits are 0. Now the second point I will explain with an example. So I have taken 7 and 4 as my numbers for this example, and I wrote over here 7 or 4. Then I applied OR operation on them. What the individual aligning bits meant was that when I converted 7 and 4 into their binary forms, there are bits that align with each other in these 2 numbers. These bits like 1 0, 1 0, 1 1 and 0 0 are called aligning bits. We apply OR operation on the individual aligning bits to get a result in binary form, meaning we will get a binary number by applying OR operation on these 2 numbers. So you see, 1 or 0 will become 1, 1 or 0 result will be 1, 1 or 1 result will be 1, 0 or 0 result will be 0. When we get this number, this binary number, the computer will convert this number into its decimal form. The decimal form of 0111 is 7. This 7 will be our final result, and this 7 will be stored inside our variable. I also wrote a more thorough explanation of this over here. I wrote an example: int a is equal to 7 bitwise OR 4 semicolon. As you can see, the first step is 7 and 4 get converted into their binary representation or their binary form. That is correct. As you can see, 7 got converted into its binary form and 4 also got converted into its binary form. The computer will do all of this, by the way. Step 2. Bitwise OR is applied between each individual coinciding or aligning bit. So 1 and 0 coinciding or aligning bits, 1 0 coinciding bits, 1 1 coinciding bits, and 0 0 coinciding bits. Step 3. The result is conducted in binary form, meaning that when we apply OR operation between the individual aligning bits, we will get the result in binary form. And step 4 is the result conducted in binary form is converted into its decimal form, and that decimal form of the result is stored inside the variable, meaning that when we apply the bitwise OR operator on 7 or 4, what happened was that the result that was stored inside the variable a was 7, this final answer. You can write this in a code as well, and you can do practice codes for further understanding, and make sure that the format specifier you use aligns with your data type, because that is what the result will come in, and it should be integer data type. Now I have presented the truth table of bitwise OR operation. You can see it over here. 0 0, the result will be 0. 1 OR 0, result will be 1. 0 OR 1, result will be 1. 1 OR 1, result will be 1. Now we will study the difference between bitwise OR and logical OR. The truth table for bitwise OR and logical OR is the same. The only difference between the operators is logical OR is used to compare and determine the true-false value of two Boolean expressions, meaning that logical OR takes two Boolean expressions as its operands and applies OR operation on them, whereas bitwise OR is used to perform OR operation on 2 bits at a time. That is the only difference between bitwise OR and logical OR. Now we will see when and where we can use the bitwise OR. Bitwise OR is used in various situations where you need to set specific bits. Bitwise OR is useful when you want to set specific bits to 1 in a binary number while leaving other bits unchanged. Now I'll explain point number 1 with an example. Suppose we have two numbers 7 and 4. We write the binary representation of 7 and 4 and apply OR operation between them. The example I've given is int a is equal to 7 OR 4 semicolon. I have already shown you how the bitwise OR operation works, so you can see that 7 and 4 got converted into their binary form. OR operation was applied between the individual aligning bits, and the result we got was 7. Now if we see the result, we will notice that when we have two coinciding bits, if one of the bits or both of the bits are 1, the result is also 1. So in a way we can say that even if we have 1 0 in our two coinciding bits, by applying OR operation we can set the resulting bits value to 1. You see there is a 0 in these two aligning bits, and we set the resulting bits value to 1 by applying OR operation between them. In the above statement written in brown, it states at the end, while leaving the other bits unchanged. This refers to the fact that if the two numbers that have been taken as operands have coinciding zeros in them, in their binary representation, when we apply OR operation to them, their value will not be changed, i.e. the result of OR operation between the two bits will not equal to 1, rather 0 or 0 will produce result 0. To combine flags or masks, OR operator is also used to combine flags or masks. In programming, flags or masks are often used to represent different options and settings. Bitwise OR is used to combine these flags or masks. Bitwise OR is used to combine flags or masks by performing a binary OR operation on the individual bits of the flags or masks. And here is how it works. Let's say you have two flags, flag A, which is 0001, and it is that this binary number is 1 in decimal form, and flag B, which is this number in binary form, and it is 2 in decimal. To combine these flags using bitwise OR, you would perform the following operation. As you know, I am sure you have now understood how to apply OR operation on bits. The resulting flag is 0011, which is 3 in decimal. The combined flag represents both flags A and flag B being set. When you want to check if a specific flag is set in the combined flag, you can use the bitwise AND operation. Okay, so now what has happened? I have explained how OR operator combines flags or masks. Now, after this statement, this point and the points after this right now, I will explain how you can check if a specific flag is set in the combined flag. This is a combined flag, and if you want to check, suppose if flag A is involved in this combined flag, you will check this by using bitwise AND operation. So for example, to check if flag A is set in the combined flag, you would perform AND operation, bitwise AND operation on the combined flag and flag A. If the result is non-zero, it means flag A is set in the combined flag. Now I will show you where this technique is used. This technique is commonly used in programming to combine multiple options or settings into one option or setting and pass multiple flags or options to a function or method. For example, in file permissions, you might have flags for read, write, and execute permissions. Now I have given the example that we set read permission flag to 0001, write permission flag to 0010, and execute permission flag to 0100. Now to set read and write permissions, you would combine the flags using bitwise OR. Now we have combined the flag using bitwise OR. This way you can easily combine and check multiple flags or masks using bitwise operations. We can also use bitwise OR operator to perform low-level programming. Bitwise OR is essential in low-level programming, such as working with hardware registers, device drives, or embedded systems. Now in my notes, I have shown you how bitwise OR operator is important in low-level programming, and I am sure that by reading my notes, you will be able to understand this concept easily. At this point, point 5 is the last point in how bitwise OR operator is important in low-level programming. After this, you can see that I have provided some common use cases or scenarios in embedded systems. for OR operator. So basically I have shown you where you can use OR operator in embedded systems. These are just examples on where OR operator, bitwise OR operator, can be used in embedded systems. Then I have explained the benefits of bitwise OR in low-level programming, especially embedded systems. By using bitwise OR, developers can write efficient, precise, and reliable code for embedded systems, ensuring optimal performance and functionality. After this, I have provided some real-world examples of use of bitwise OR operator. Now we are near the end of the video, and I will conclude the video by giving you clear, concise images of my notes. You can take screenshots of these notes and pause at any given moment in the video to see these notes clearly. After reading these notes, I am sure you will be able to understand the concepts related to bitwise OR operator, and I do hope that you will understand this concept clearly and it will help you to get a thorough grasp on the concept of bitwise OR operator.